In this video, we're going to look at the problem of finding the minimum value for 16x squared plus 4y squared, subject to the constraint xy equals 2. Okay, so the first thing we do is we find the gradient for each one. So this is going to be 32x, and the gradient of 4y squared would be, the derivative would be 8y with respect to y. Okay, and then gradient of g, which is the constraint, which is this guy right here, that's just going to be yx. So next, we note that neither x nor y will be zeros in this case, because we need to, our critical point has to satisfy the constraint x times y equal 2. So x cannot be 0 or y cannot be 0, because the product of them will just be 0, not 2. So we can go ahead and just divide and set up the proportions. So we've got the following proportion that is going to allow us to connect x and y. And so what that means here is that if I can solve this for y squared, 32 over 8, that's 4x squared. Okay, so what are my critical points that would satisfy this constraint and this condition? Okay, so the constraint is x times y has to be 2. Okay, so if I were to use the square root of property, that'll tell me that y is really plus minus square root of 4x squared, right? But that's just going to be 2x. So y is going to be either positive 2x or negative 2x. So let's just say y equals 2x first. That's number one. Let's use the constraint. So that's going to be x multiplied by 2x equals 2. So this just tells me that x squared equals 2. No, not 2. 2 and 2 will cancel. So x squared will be 1. So that tells me that either x equals 1 or x equals negative 1. So if x equals 1 and y equals 2x, so that's going to be 2. So that's one possible critical point. And then negative 1 will give me negative 2. So far I found 2 of them. Now the second case, what if y equals negative 2x? Well, if we substitute that into the constraint, then we get x times negative 2x equals 2. So that's negative 2x squared equals 2. And that means that x squared equals negative 1. But there is no real solution there. So I don't think I have any other points. So I just got 1, 2, and negative 1, negative 2. Okay, so let's go ahead and substitute the points, and I think it'll probably be the same because you're squaring everything here. So we're substituting that into our objective function, the one we're trying to maximize or minimize. And we got 1, 2, and we also got negative 1, negative 2, but both of them are just 32. So how do you know that this is really going to be what he says is a minimum, but how do we know that? So we already know that that's going to be 32. But why is that a minimum, not a maximum? So if you take another point that satisfies this constraint, x times y equal 2, if you plug it into the function, you will get a number larger than 32. Okay, every time, no matter what. So let's just try that. Okay, so let's just take any other point other than 1, 2, so that x times y equals 2. Okay, so for example, if x equals 2, then y will be 1, right? So and then it'll satisfy the constraint, and we can see that that's a larger value. So 32 is really the minimum, and you can keep trying, but you already know that it's not going to be a maximum because you just found a point that belongs to the constraint for which the value of the function is larger. So it has to be a minimum.